Okay, so in this video, we're going to graph y equals x cubed plus 5. So similar to graphing quadratic functions, we should know the basic orientation of the graph of x cubed. If you remember, adding a number, subtracting a number will just move will just move the graph by a certain number of units depending on the numbers that we use. So as you can see on the given function is y equals x cubed plus 5. So let's start with the basic orientation. How do you describe the graph of y equals x cubed? Y equals x cubed before we do a plus 5. I'll give you options. Is it like this? Is it like this? Is it like this? Or is it like this? A, B, C, and D, or none of the above, letter E? D. Okay? So it's like a twisted graph, twisted curve. So the graph of x cubed should follow this orientation. Okay? Now, if we have used the tabular method, the best choice for this will be -1, 0, and 1. Okay? So, let's use that. If we have a table of values for y equals x cubed, I have x, y. So for basic graphs, our options would be -1, 0, and 1. If x is -1, what is the value of y for y equals x cubed? If x is -1, what is y? What do you think? Sure? If I put -1 here, what will be the y? Jong?
Yeah.
What is y when x is -1?
-2.
You sure?
-1.
-1. If x is 0, if I place 0 here, 0. If I place 1, 1. These are the points that you need. So 0, 0 will be at the origin, -1, -1, +1, +1. So you have 2 more points. But we know that the graph should look like this, like an S. So when we connect, it should look like this. Okay? So it should pass through the 3 points that you have identified. Okay? Now again, if you observe this is always 1 unit, 1 unit, 1 unit, 1 unit. So it's easy to find. Clear? Now, we changed it a bit. We added a 5. So how will this +5 affect the graph? Again, we said this will just be a movement of the graph. And that is the graph of x cubed. So how are we going to move the graph of this to obtain the graph of x cubed plus 5? You sure? Any idea?
So going up.
Going up by 5, correct. Okay, so this is your basic graph. The graph will be moving up 5 units up. Okay, 5 units up. So if we make a new graph, so that would be, so let's make an x and y. So from 0, 0, it will be moving 5 units up. So 1, 2, 3, 4, 5. This will be your new 0, 0. And I said, it's always 1 unit, 1 unit, 1 unit, 1 unit, so that you can make a new graph. And that's it. That's your graph. There's always 1 unit distance to find the other points. Yeah, of course, it's recorded. It's okay, this is for you. Okay, questions? Let's go to a fractional graph, function rather.
Quadratic, and then this is
Cubic
cubic.
functions. 3C, the graphing. Okay, so you're interested with this. It's equal to 1 over x minus 2. Fraction. What kind of graph do we have? This came from,
Sure, that's a V. Is that a V?
this is not the V. This is the mirror graph, like this. Okay? Get it, John? So you expect a graph similar to this. But you have minus 2. This is like the one in the parenthesis. So you have minus 2. Imagine if there's a minus 2 in the parenthesis, how will that move our graph? Yes, Richard?
You move the graph to the left, to the right 2 times.
2 times, very good. Okay, so this is the basic graph. So if we are moving it 2 units to the right, you just move the axis, not literally. So you're just moving the guidelines. So from y-axis, this will move 2 units to the right. So 1, 2. So as not to confuse yourself with the original x and y axis, you make a dotted line. Okay? Now there's no plus outside the parenthesis. Okay? There's no plus or minus. Usually that will make the graph move up and down, or up or down. But we only have minus 2 on the x, so it will just move to the right. So the x-axis will not move. So when you graph, since you know that this is the basic orientation, this will be your new guideline. So this is the vertical line is now your original y-axis, and same x-axis. So if I have to graph it, so I'll be using those lines. You are not allowed to cross those lines because they are asymptotes. And then on the other side, you have to create a similar graph as the basic function. Okay? Now to expand the idea, what if I put a negative before the function? Say, if I will make it something like f of x is equal to negative 1 over x minus 2. So it's almost the same with the first one, except that there's a negative sign before it. What is the effect of this? Remember the effect of the negative on the parabola. What happened to it?
It turned upside down.
Upside down, right? So it reversed the orientation. So for y equals 1 over x is the same thing. So if you look at the graph that we had a while ago, so the orientation is that this is on the first quadrant, this is on the third. So when you twist it, so it will move down. This graph will now be like this, but the other side will be on this one. Can you follow? Okay, so only because of the negative. That's the effect of the negative. Is it clear? Clear? Okay, good. So we...
Just like here.
Yeah, so this one, so let's make the actual graph. So it will be, so minus 2 still be moving by 2 units to the right. So guideline. But instead of making a graph here, so you should make a graph on top and then below here. So just reverse it. Okay, clear now? So you know how to graph something with a number over x. Okay, so that's all for now. We'll be discussing the other items in the next video. So that's it.